So welcome to the last session. That's going to be a panel discussion. We have a number of different perspectives on this panel. I'm going to just briefly go over them, and then we're going to give them a chance to introduce themselves very, very briefly, and tell us a little bit about their journey to Kokkos. You know, how they got tricked into using it. What do they do with it? You know, as a contributor, the users, and whatnot. So briefly give you an idea of how it's composed. So we have an application specialist, Julia. We have Luc, who's the lead of Kokkos kernel. We have Cedric, who's from CA and who's playing a leading role in one of the new experimental libraries that we have. We have Martin, who's an educator, but also a pretty advanced user and contributor. We have Jakob, who's a developer in the core team, a new addition to the team. And we have John Chao, who's working on a scientific toolkit, and you've seen his presentation earlier. So we're going to go in order like this. I will ask you to stick to 4 minute maximum. So again, you introduce yourself briefly and tell us a bit how you got to Kokkos. So we're going to start with Julia.
Yeah, my journey to Kokkos was very short because we were basically told that Kokkos is our performance portability strategy in the Sierra suite of codes at Sandia, right? And also because we're at Sandia, we use Kokkos. At the time, so it was probably about 2016 or 2017. Was my first exposure to the Kokkos library, and I was coming from grad school where I had done a lot of work with OpenMP programming. And so my impression at the time, I think, was that Kokkos was kind of the minimum subset of capabilities that were common with all these different parallel, libraries and tools and things that promise to allow you to run threaded or with accelerators. And I think, over the past almost 10 years now, I've seen the tools and Kokkos core and Kokkos kernels grow pretty tremendously. And the thing that I think is really cool about it is that in our applications, it allows you, I think I alluded to this the other day in one of the panels, that it allows you to do really simple things, but it also allows you to do really complicated things and really dig down into the details. And I think that's by virtue of not just having a nice API, but also by having really nice tools that come along with it. So I think, my experience with Kokkos has been with pretty much everything, all the packages, Kokkos tools, Kokkos core, containers, Kokkos kernels. And my team, I would say, for those who have an appetite for doing performance portability work, which you have to love it, you have to want to do it, right? It's been pretty easy for us to pick up and use and be successful and tune what we're doing with the tools to have a code that works pretty well on accelerators. So so I've been a user of Kokkos. I think maybe I have a couple of pull requests floating around, but I haven't really contributed a whole lot to the Kokkos ecosystem. But certainly, we're very heavy users and pretty knowledgeable about what's there too. So that's my Kokkos story.
Thank you, Julia. And before I go to Luc, I forgot to mention, so we're going to use the same platform that we had used the other day in the general session. So I'm asking those who have a computer or a phone, which I think it's most of you guys, to go, and there are already a few stalker questions. So if you like them, you can just vote them up. And what I would really appreciate is if you also ask some other questions. So please go there. I'm going to leave this slide, but ask your question. So now we're going to go to Luc.
Okay, so I'm the currently the lead of the Kokkos kernels teams. I've been at Sandia since 2017. I started as a multi-grid developer, so working on the Mulu package of Trinos. And pretty rapidly, we've had to adapt some of our implementation and algorithms to run on GPU, and was always pretty enthusiastic about it. So I quickly joined the Kokkos kernels teams as a second team for work at Sandia, and grew in the algorithms that we're developing in the various platforms. I also enjoy the fact that Kokkos kernels is partly at the intersection of many user teams that have various applications and requests, and so we see a lot of variety of physics and applications, which I think is pretty interesting. And right now, I guess one of the focus is, at least in my mind, making the library more robust, more production ready, more uniform, give it a good feel for users. I hope more usable as well. I think that's covering it up pretty well.
Thank you, Luc. So now we're going to Cédric.
Okay, so I'm Cédric Chevalier. I work as a computer scientist at CEA. The first time I heard about Kokkos was 17 years ago, when I was a postdoc at Sandia, and it was even before Christian came to Sandia, and it was the first version of Kokkos, and the goal was to have TBB on GPU. It was not very successful, and what I really like is they analyzed the problem and they saw that they had to tie the data with the parallelisms to achieve performance. And since then, I was following what happened to Kokkos, and I was a Trinos user for linear solvers. And 2 years ago, at CEA, we had this project to contribute to Kokkos. So now I am part of this Sexa project, and I try to follow what is going on Kokkos core, and we try to do this Kokkos.com project to ease the use of Kokkos in the context of distributed parallelisms.
Just out of curiosity, how was it called 17 years ago? Was it already called?
It was called Kokkos, and the next version was called Kokkos Array. And after they get rid of the array stuff.
So you're saying Christian is rewriting history when he's saying it's 12 years ago?
I think you can ask Mark.
Okay. Thank you. So now we're going to go to Martin.
Okay, so I can take you back in history as well. So my journey with Kokkos started 15 years ago when I was a postdoc with Roger Ganem at the University of Southern California. And Roger developed the surrogate modeling approach, the polynomial chaos, in uncertainty quantification. And so at some point he wanted to push this approach to really bigger problems. And so he was looking for collaboration with computer scientists, and he was developing this collaboration with the Trinos group at Sandia, with Mike Heroux. And Mike Heroux told him, well, we have this Trinos user group meeting next week. Why don't you come? But of course, Roger's schedule was full, and so he sent his postdoc, and so that's how I got to know the group at Sandia. And ever since, we've stayed in touch and collaborated. So at some point, Eric Phipps started working on ensemble propagation, which is sort of using SIMD types for UQ with Kokkos, and I thought that was really a great approach, and so that's how I got into really trying to understand Kokkos. These days, Kokkos is a great community. It's very high-level coding, so going through Kokkos code, you learn a lot, and when you contribute to Kokkos, you kind of know that your contribution will be valuable to the community, and that's really nice. These days, I have a research group at the University of Liège in Europe. One student, we have a PhD project contributing to the Kokkos graph. It's with Romain, Damian is also involved in that project. And increasingly, I also use Kokkos and Trinos in classes that I teach at the university.
Thank you. And that makes me think that Michael Heru had pointed out to Christian actually some paper we had never heard of from 2010. And so we are actually going to write some kind of Kokkos history paper, and we're probably going to ask you, Mark and Martin and Cedric, to verify what we're saying. We're really interested to see where the roots. Okay, so now we're going to go to Jakob.
Okay, so I started at Oak Ridge in last November, so I'm basically the most recent addition to the Kokkos developer team. How did I get into Kokkos? That's kind of a nightmare. So for my PhD, it was someone came with the question to my institute, which in Munich, which does helicopter simulations. Can you do sit a pilot in a simulator and have in real time a fluid simulation on the side that computes the flow around the helicopter, basically the helicopter wake? And we were like, yeah, okay. Or my professor was like, yeah, we can, if you give us money, we can look into that. And we started that. And then he asked me if I was still a master's student, if I want to do this. And I looked through the list, they gave me what they wanted, and it said real-time capable. And I was like, yeah, how hard can it be? That's where the nightmare started. So yeah, getting something meaningful from your computer within the update of the simulator was 100 hertz, so a hundredths of a second. Getting any meaningful fluid simulation, that time span is borderline crazy, I would say, now. So we started digging, how can we do this, and what solver can you actually use, and how can you accelerate it to do something meaningful in that time span. So I ended up doing CUDA. And we looked into, back then we started looking into Kokkos because okay, do we need to do all of this ourselves, or can we just get a library that already has that? But unfortunately, the code owner of the code that we were working on, that back then was only CPUs and we needed to port that, was against any external library, including the standard. So they had their own implementation of vector and stuff like that. So everything that you don't want to have was in that code. Everything was raw pointers. Everything was the 90s development style. Everything was classes. Everything inherited from everything. So my office mate and me, who also worked in a similar project, we looked into Kokkos and we're like, can we not kind of push this onto this project, that we can use this? Everything would benefit from it. We got shut down hard. In the end, we caved and we did a manual implementation in CUDA. So I tried to do my PhD and just move on with my life. And then towards the end of my PhD, I was like, maybe this idea of doing something that actually sticks around and makes this more usable lingered around. And at one evening, I just wrote an email to Christian, like, hey, you're doing this Kokkos project, could I just join as an intern for some time? And to my surprise, they actually replied. And he said he can't do it, and he referred me to Damien. That's how I started at Oak Ridge, basically. And I could transfer, because I went through the nightmare of having to do all of this stuff on your own. I could kind of transfer some of it to Kokkos and see why it's so useful. And that's how I ended up doing Kokkos, because I think it's actually useful to not have PhD students, or anyone for that matter, go through the nightmare again and again and again and again for every new vendor, for every new library, for everything, like every new code. That's how I ended up being affiliated with Kokkos, basically.
Thank you. By the way, I don't think you're the latest addition to the team. I'm pretty sure Travis and Paul arrived after you.
Oh, okay. Sure. Then I give that to someone else. You want to switch, Travis?
So, and our last panelist is Jun Chao.
Hi, I'm Jun Zhao from Argonne. Currently, I'm a software engineer. I come to Argonne long time ago. I was in the MPSH group. At that time, I was working on MPI 14208 binding and MPI performance war and control variable, these things in MPS that I felt isolated from users because few users actually use MPI 1408 body. So by chance, my EX supervisor Barry Smith had a LAMP LDRD project on new program model. So he sent out an email to the division and looking for collaborators. So I contacted him and joined the PACY team. And Barry Smith mentioned the Kokkos to me. I guess it was 10 years ago. And Barry said, the Kokkos, our idea is different from Kokkos. So I searched the Kokkos and read the Kokkos slides, the documentation. And I thought, actually, we were solving different problems. So Kokkos is good, but it does not fit us because in PACY, at that time, I know the Kokkos is to write a single source code for OpenMP and CUDA. And in PACY, we do not use OpenMP. So why we would use Kokkos? So I just threw the slides away. And years later, when we come to the ECP project, we, as a PACY team, have to support multiple GPUs. But how to do that? That's a problem. PACY developers had a confusion and a debate whether we should create a new backend for heap and another for SQL. But how to handle the code duplication? We didn't know how solution. I looked around and picked up Kokkos again, and I said, why we just stop debate and try to do a demo to implement a prototype. So I secretly worked on PACY Kokkos backend, and then at our PACY weekly meeting, I presented my impression and did a demo. And my colleagues, my supervisor were shocked to see the prototype. They say, okay, there's a portable backend and it works. So that started my journey of Kokkos. And then later, I added more features, Kokkos things to PACY and make the PACY Kokkos backend more capable. And I built a connection with Luke, Kokkos kernel developers, and Daniel, host developers. So that helped me solve a lot of issues, problems, bugs, and we make the PACY Kokkos backend stronger and stronger. And as I mentioned in my talk, I saw more and more PACY users starting use PACY Kokkos backend. And so I feel I got busier and busier to answer their questions. But it's good.
Thank you all. So we're going to move to the questions from the attendees, and I suppose I'm going to just respect your your choices. And the first question for you guys is, why is Christian not here? Did he leave the project?
Okay,
Christian who?
Christian who, yeah. So, for those of you who don't know, Christian is already interviewing for citizenship today. So that's why he's not here. And that kind of was more important than you guys. To him, I guess. Don't kill the messenger.
Anyone wants to comment? Okay. So the next question is, what's your personal pet peeve with the Kokkos code base?
Our personal what?
Your pet peeve with what you really, really dislike in the code base.
Okay. Who wants to start?
Okay, I can say something. I don't think it's a pet peeve. I think it's something that's not that's in progress, and that I hope will get to the point where it becomes really solid and usable. But currently, the SIMD implementation is not done in a way that's allowing us to, like, say, leverage in Kokkos kernels in an easy way. And I think it needs to be pushed further, made portable so that it can be, combined with code that's portable itself on, CPUs and GPUs, and that would help a good amount for performance, because it would make it easier for us to, leverage SIMD capabilities. And Kokkos kernels has re-implemented SIMD capabilities in our own library, and I think it's unfortunate that that's what we decided to do.
I would say the fact that the execution policy contains the execution space. So if you do parallel for policy, maybe you want a policy only to decide the index range, not necessarily the execution space. I would separate that out.
With apologies to Luke, some of the support in between the Kokkos core and Kokkos containers and the Kokkos kernels tools aren't fully consistent. I can find holes every once in a while, but luckily they're right next door, and so we can put in requests or we can put in pull requests, right, and to the team, and they'll get them addressed really quickly. I think, like, working on one of the big codes at Sandia, that's one of the things is you guys are always really receptive to kind of accommodating our needs. And I think we have a lot of very funny CMake options and things like that, right? And ways that Kokkos have specifically broken for us in our production level applications. But it's nice that they're there, and it's nice that we can keep running even with newer versions of these libraries and tools. I think another big thing for our legacy C++ apps that are developed where everything depends on everything else, right? Everything's polymorphic, right? Because it's cool to make everything virtual, or it was back in the day. So for us, just generally portability of C++ code that relies very heavily on polymorphism is a pain point, and Kokkos helps with it, right? But there aren't tools to make sure that you get it right every single time. So that can be really hard to deal with. Yeah.
What containers do you guys use?
We use views, we use dual views, we use some dyne-rank views. We use... Is the CSR matrix stuff in containers?
No, we got rid of it. We found other suckers to get it.
Yeah. Okay, so there's another pet peeve when things change locations. Sure.
So all your phones are causing feedback to the point that the recording will be unlistenable. Could maybe move your phones.
Airplane mode?
Next time it's going to be an exam. Travis is gonna.
And I'm going to read the question next to Daniel again. Do you know why we have all the containers in a different directory?
No, I don't know. Sorry.
Because it's easier than to do git remove. Okay, who's next? What's your pet peeve?
So I will say the execution policy that stores the iteration space is a kind of a pain when we want to add some wrapper on top of Kokkos. Okay, and else I think the MD range policy also is currently you have to do specific code when you want to deal with rank 1 views, and it's not very consistent, and the tiling parameters are not trivial to understand, and I think this can be improved. It can lead to weird results when you have you first use Kokkos, and I think when you begin, it's very important to be easily understand to easily understand the results of what you are coding. So yeah, I think it's my main complaints, I would say.
Junshou, do you have a pet peeve?
Yes, generally with C++. You know, PASI is written in C, and we use word porter to separate C and C++. And when in debugging, sometimes I need to cast a word porter to C++ template structure, and I didn't know how to do the casting. It's very hard, and it caused angry in PC developers. So for C++, and for Kokkos, basically on documentation, either in Kokkos or Kokkos kernels. I read the documentation, the wiki, and there are some code slip, but it's incomplete. I could not directly run that. To play with, to quickly get things from the code block. And by the way, in PC, all code snips are from PC test or examples or tutorials. So it's always working, and users can directly pull out the test and run them. So maybe Kokkos can also learn from PC.
Maybe you can educate us on how to do it better. So Jacob, you're living under the hood, so you're only seeing,
I feel like this is a trick question for me, because everything I'm going to say, he's going to assign me to. So I'm maybe just going to do the smart thing and say the thing I'm already assigned to, or am already doing. So I don't know if you build, I hope no one here builds Kokkos with make files. If so, you're going to be in a bad spot soon. But if you use CMake, our CMake build system is incredibly invasive on everything downstream. And this is just like we want to, or we as a library try to be minimally invasive on your code base, but for the build system, we are maximally invasive. We're doing exactly the opposite. So we just said, for example, we force you to for example, for NVCC, to use our wrapper, just defying anything that CMake wants you to do. We just say, don't care. We just do it. So we are in the process of cleaning that up. But this is something that kind of goes against our own policy of not being invasive. So yeah, but I'm already working on this, so he cannot assign me.
That was very very small. So the next question is a little bit similar. So they're asking you what horrible feature you think should be immediately removed from Kokkos.
Oh boy. Who wants to go first?
Why do we have to focus on the negatives? Gosh.
I like that. I think we keep it all. So, and there's another other people missing question. Okay, so I'm going to take one that's quick to read first. How future-proof do you think Kokkos is?
Maybe I'll chime in. So something that I forgot to mention during the introduction for myself. One thing that I like with working with Kokkos and Kokkos kernels in general is that we see a lot of the early access platforms because Kokkos is a portability layer, so it's nice to have like that stuff work so that then the applications can come in and the libraries can come in and they're like, hey, we already ported our code to Kokkos and Kokkos already is going to deal with that new architecture, so we can just go and do stuff. And that has worked on some platform in the past. For example, at Sandia, we have this platform called Astra, which was a computer using ARM CPUs when ARM CPUs hadn't been put in, I think, HPC server at the time. It was pretty new. And that, I think, maybe Julia has a different experience, but I think it was fairly successful in general. Like things worked pretty well, not necessarily because of Kokkos, but so that's something that's interesting. And so, in terms of future-proof, I think the next generation of platforms that are going to come are widely different from what we've seen so far. If you think GPUs were a problem and complicated and annoying because they don't look like CPUs, please buckle up. I'm going to bet that in 10 years, when you have to leverage many weird accelerators, potentially including a quantum one, you will think that GPUs are just the tamest things we can think after the CPU. And so how future-proof we are in Kokkos to potentially support all these things, I don't know. So the good news is there's potentially a door opening in the future for other libraries that will have the benefit of the hindsight of like, hey, we didn't write Kokkos, so we can start from scratch and do something that supports other stuff where we cannot because we already have our APIs and our containers and all that stuff. So I don't know that it's so future-proof, but I think for GPUs we have a good road ahead of us to support them and support the current architectures that exist. Just maybe not the next 1 or 2 generations of crazy hardware.
Yeah, for us, I think the abstractions have worked out pretty well so far, in the sense that, like, for example, we wrote a lot of really simple Kokkos code that was all based around default execution space and default host execution space and default memory spaces, right? And when we flipped the switch and turned on unified or shared memory spaces, it mostly worked. There were some minor fixes, and then we were up and running, right? Running our tests successfully. I know that's not uniformly true for all application codes, right? Like, I think there's a developer of one particular project in the back where I think they made some assumptions about what things were going to look like in the future with regard to Kokkos, and are kind of paying the price of that right now, hand rolling some abstractions that Kokkos had provided to make them a little bit lighter weight, maybe with Christian's guidance, to be fair. But so, like, I think like if where we've written Kokkos-y things and done sensible default things and kind of like done the right thing from the perspective of the API, we've been pretty successful. But there are definitely gotchas when you try to sort of optimize under the hood and the underlying assumption changes, right? It can be hard for some of the other app and library teams. And that's just what I've seen.
I mean, if you maybe go away from Kokkos as a library to Kokkos being an idea, then it might already be answered. Like, for example, with MD-span in C++ now, basically something that originated within Kokkos, or is at least tightly related to Kokkos, made it into the standard. And if you look at how many people in the Kokkos team are actively working in the standard committee, these ideas are already standardized, and the knowledge that we, or the usage that we saw, and the complaints that we got, and all these iterations are reused basically and get into the C++ standard. So I guess as an idea itself, like this, we want to standardize how you use accelerators and how to make it easier for the user. This already will or is codified into the standard. It is living on. It's not going to go away soon. So it is kind of future-proof, and Kokkos already proved that the ideas it has are future-proof by them getting accepted into the standard. If tomorrow someone comes up with an accelerator that our programming model will fundamentally not be able to incorporate, we don't know. At least I don't know. And this can always happen. Then maybe someone else comes up with a new idea of how to abstract stuff away, and that makes it easier for the user. And hopefully at some point this also gets standardized and gets basically codified for mankind to use for however long it's useful.
Yeah, I think about future-proof, it's as future-proof as the other popular way to program accelerators for now. And what is really interesting with Kokkos, and I have been using Kokkos for co-design since a long time, it's you can also compare backends. So if, let's say, OpenMP target improve a lot, you might be still be able to use Kokkos in this kind of application. So I think Kokkos is a pretty robust way to handle the future. But if we have a very disruptive programming model, perhaps we will have to switch to something. But perhaps also we can we will be able to exploit the Kokkos view and this very small programming model to be able to use data flow accelerators or this kind of stuff.
Any more reaction? Yeah.
And I think with C++, Kokkos is already future-proof. If something new appears, you just need to override the old one and derive new classes. And with so many Kokkos users, if something changed, users will sense the change earlier and give you feedback. So Kokkos will adapt to the changes. And with so many code already written in Kokkos, and sure, Kokkos will last. Otherwise, how to deal with the code? I recall in a talk I heard, currently there are more than 200 billion lines of code in COBOL, COBOL, COBOL. So you can imagine with so many Kokkos users, this code will last, and Kokkos will be future-proof and supported.
So it kind of depends on what you see as future-proof. If it's future-proof for your job, okay. If it's future-proof for new things showing up, we'll see. I mean, that's at least how I see it.
Okay, I guess I'll say one more thing that's good with this, and because Kokkos has a pretty good user platform and community, and has, I will say, so far pretty good partnership with the HPC vendors. I think we have the opportunity to be well engaged in co-design when changes happen, which is a great opportunity to keep being at the forefront of this evolution and be future-proof as well. So I think that's a good position and opportunity that we have. Yeah.
Yeah, it definitely could be worse.
It could be worse, yeah.
I think that one aspect of being future-proof is that we arrive at attracting sort of the next generation of people to the project. So that means the next generation of students and make our project accessible to them and attractive to them. I think that's challenging. In my own career, I try now to integrate Kokkos in courses at the university. And we see it's not obvious because we are continuously increasing the standards of our coding. So we use very complex concepts from C++, which are not easy for students. And Kokkos also uses abstraction a lot. Like the patterns like for, reduce, scan, they're not necessarily accessible or understandable to students immediately. And so I think we should pay great attention to collaborate with academia to make sure that the concepts we work on are part of the curricula and that students are prepared to join projects like ours.
Okay, we're going to go to the next question. So the next question was, are really sometime kernel not portable? And in that case, like meaning you would have a very different OpenMP optimized implementation from a CUDA implementation. And what advice do you have in this case if they exist?
I guess I can start a little bit. So in Kokkos kernels, we implement a lot of course, math algorithms, and with various success, we also wrap up the TPLs of vendors because it's hard to keep up with all the changes and all the optimization across platforms. We have observed that just fundamentally the architectures of the CPUs and GPUs are different, and sometimes you want to expose more parallelism, sometimes you want to expose more reuse, you know, on the CPU cache hierarchy that can pay off better than exposing wide parallelism. One example is when I joined the group, my colleague Siva was working on the graph coloring algorithm, and he showed that for a CPU-based algorithm, coloring based on a sweep over the vertex was a good idea, led to pretty good performance, and versus on the GPU where he was doing a sweep over the edges, and you have way more, typically much more edges than vertices, and expose more parallelism. So fundamentally, it was just thinking of the algorithm you're trying to implement and the capabilities of the architecture. And so it led to two interesting implementations that are more or less performant on each architecture. Then once you're arriving at that point, if you write a library, it's nice to try to offer good default values, good default parameters for your users so that it's simple for them to land into the correct implementation. But you know, fundamentally, if the approach is different on the two different architectures, you have no choice. You will have to adapt your implementation to do it correctly on a given architecture. So,
I think my answer is get Christian Trott to sit next to you, and he'll start counting flops and registers, right? But in seriousness, I think this is something that's really been a struggle for us for a long time, right? Because even when we started looking at, you know, NVIDIA profiling data, right, and looking at like trying to optimize certain metrics like occupancy, load efficiency, store efficiency, all these sorts of things that you can do, right? Like we would change things and randomly and nothing would happen with our overall performance, right? But I think just holistically looking at our code base and targeting what to port, I really advocate for taking a data-driven approach, and I think like the Kokkos tools can help out a lot with that. Just trying to drive certain metrics down about certain bits and pieces in your code, and they can, you know, like a lot of the tools like HPC toolkit here as well, right? Like can point you to gaps or pieces in your code where, you know, maybe you had a hole in your timer data, right? And you didn't know that that was there, stuff like that. So I think like taking a holistic view to the code base and getting the small wins, getting like a lot of small wins where you can is a really important kind of philosophy. But as for porting individual things, I don't have that much advice.
Yeah, I think for some kernels also we can do things a little bit better. For example, if you are using SIMD, it will be harder to port it to GPU, and you will have to duplicate your kernels. And that's perhaps something on the core library that can be improved to help to keep this one code, multiple devices paradigm. Else, after I think it's really a trade-off. If you really need highly optimized kernels, I think it's okay to duplicate the code, but you have to compare very often to a more naive implementation to see if it's worth it to keep the highly optimized version.
So maybe I can add a little bit of context from the nightmare. So one of the things that we were doing, or I was doing at the Institute, was we had the problem with writing all of this ourselves, that CPUs and GPUs are fundamentally different, and our algorithm would either be good for GPUs or good for CPUs. We didn't want to have to keep two versions around, because we separated individual bits, individual functions into functions, because you don't want everything in one file and in one big function. We ended up with like bad caching depending on how you would, if you would do call by value or not. And one thing, we tried both of them. We tried first doing it for GPU, then we realized, oh, our CPU performance is pretty bad now, so we tried to mangle them together, and in the end everything was templated and it was like a huge mess. And then a coworker showed up and was like, why didn't you just push all of these things into one big function with another language? And sometimes it still makes me think sometimes for these, like if you ever hit a problem like that, I would not recommend this as first approach, but if you ever find yourself unable to, with tools like Kokkos, manage to get good performance on these architectures, then maybe you need a bigger gun. And for us, this bigger gun was, okay, we're gonna use symbolic Python, we're gonna give it the math that we actually want to do, and we're just gonna generate a kernel, one function that has everything that we want computed inline. It's unreadable for humans, if it's undebuggable, you're just gonna have to hope that it works. Sometimes it goes off the rails, no one knows where. If it goes off the rails, it derails completely, but if it doesn't, it works. And this can basically, or gives you more flexibility in tackling these things, but you end up, like, there's no free lunch. You just end up with something that's impossible to debug, that just might not work, and you don't know why, and someone comes to you and asks you, like, why doesn't this work? And you're like, we have absolutely no clue why this does not work. It worked before, it does not now. But you can, like, Kokkos is not the only approach for stuff like this, and sometimes, like, just thinking outside of the box, if you find yourself really tasked with something that you could not tackle with the tools that you have in the box, might be worth a shot. But I would say do this as a last approach. Try to do it in the box first.
All right. I assume we're done with this question. So the next question is one of the goal of Kokkos was to disappear into the C++ standard, whether it was by standardizing some of the useful features that we had, or by reusing things that were brought by the industry. How much of it was already achieved?
That would be a question for Christian. Or Damia, for that matter.
I am not sitting here, so.
I think there is still quite a bit of a road ahead of us. I think Kokkos has an aspiration to standardize things, and for good reasons. The vendors usually ship their machines with compilers, so they have high opportunities to tune and implement very efficient versions of, say, certain libraries that the standards might codify, and so down the road, basically it leads you to a code that you can link against the standard libraries and get all the benefits of the vendor's tricks and optimization. So that's a very good thing. On the other end, I think as soon as we finish a feature and we standardize it and we socialize it, etc., we are jumping on the next one. So it's going to be the internal, chasing your own tail of like, oh, now that this is done, there's the new thing that comes. And I don't think we will ever be fully done, because that's the nature of the game. But I think as long as we can keep on making progress on standardization, it will keep the load of maintenance in the library at a sustainable level, where the new features replace the old ones, and we have hopefully a constant load of things to maintain that's not yet standardized. That's my hope for it, at least.
Yeah, and like if you just look at how long it takes for something to arrive and then is tested by multiple users, multiple institutions, and then until it reaches the level of maturity that it can actually be considered for the standard, this is quite a long time. And all the time in between, like, you're not going to sit around with your computer and be like, oh yeah, we're just going to wait. So you want something in between. So I guess we will try to continue being on the forefront if there is something new popping up in your architecture, some new abstraction, whatever. And slowly on the backside, basically trying to, as soon as we think we have enough experience with it and it actually makes sense to push it into the standard, like propose it and then see how the internal iterations there go. And so it's just going to be a continuous thing. It's not going to be just rename everything that's in the Kokkos namespace to std and then here you go. That's not going to work.
So Kokkos View has been pushed into the standard as MD-span, more or less. If we think about Kokkos, it also has this descriptive strategy that people talked about. So you describe what you do, and then Kokkos behind you, underneath, is going to decide how it does it. And there's many optimizations in Kokkos for how to launch the work. If you take a look at the new proposal, like the stud execution, there's many of the same patterns in stud execution. But if you look at the reference implementation of NVIDIA, it doesn't have these optimizations that are under the hood in Kokkos. I think there is a very big, very rich content in Kokkos there that is not yet standardized in the standard.
Yeah, and it's more an external source, but I'm not sure it's really a goal to be now in the standard, because the vendors are not standard. CUDA is not C++, IP is not C++, SQL is not C++, so we do a C++-like interface on top of that, but if we focus only on the standard, perhaps we will be less agile to integrate new hardware and new language as a backend. So I'm not sure the goal is still to be in the standard. I think it's to provide stuff in the standard that will help us decrease the burden of maintaining Kokkos, but I'm not sure the end goal is to put all of Kokkos in the C++ standard.
Okay.
I think standardization is very important for Kokkos to grow. If you have some very good features, ideas that are standard, then vendors will need to support that. Then it will bring stronger interoperability. between vendor libraries and the Kokkos, basically C++. And recently, I remember a post from Arc Slack channel. A user played with Kokkos construct within SQL, and he said, "Wow, it worked." I think that's because of this standardization. You implement something the C++ needs, and interlock and the C++ stand and supported. So I'm Saba for standardization.
So the next question is, should there be a Kokkos specification?
Who is going to do that? Who's volunteering?
We have a volunteer there.
No, I
So-
completely agree about that. Yeah, I was going to say it's maybe we would benefit from explaining what a specification is potentially, but if you think of the C++ standard, when you go read the specification for it, everything pretty much is spelled out. Everything has to be in quite detailed explained in terms of how it happens, what are the guarantees. We enjoy living at the bleeding edge. We enjoy having the freedom to experiment and back out and bring back stuff and rewrite them. And sometimes, it means we're a little bit fuzzy on what we intend to do at the beginning. Sometimes we're a little bit fuzzy onto some guarantees we'll have in terms of side effect or precision at which things are going to be done, etc. And that allows us to iteratively refine, our understanding of what the users need and what the vendors can support. And eventually, the end product of these things can be the Kokkos view that is refined into the MD-span, and that's something that goes in the standard. But I don't think that the whole library should be, asked to be at the same level of specification. I think it would be a very difficult thing to achieve, and it wouldn't serve the users.
You basically just make everything super stiff. Like
It's
once
also-
it's specified, it's here you go.
You can implement it the way you want, but
Yeah.
you have to be very clear. It's a very slow process. There is a reason why it takes a long time to get Kokkos view distilled into MD-span and MD-span into the standard, and same thing for stud executors and the SIMD also. SIMD has been around forever. For a long time, and now the standard is looking at it. There are reasons why these things are not that fast and are left somewhat, in the gray areas of how to do things, etc. And that's fine. Not everything needs to be 100% precise all the time. I think as long as we have good documentation and we can put notes and warnings like, hey, this is something that's subject to some, changes in the future for various reasons, this might be okay. And then you can stay away from it if you don't like this piece of, feature that we're providing. It's okay.
Yeah, I tend to agree on I think newer C++ feature like concept perhaps will help to understand better what are the requirements of the current implementation. And by doing specification, for example, if we look at OpenMP and OpenMP target, they had to release very often new version because the implementation are moving and the hardware also is moving. And I remember for example, the NUM team's argument was not interpreted the same way by NVIDIA and Intel, and they had to be more precise in the next iteration of the specification. So even if you have a very complete specification, it will still be not enough. So I'm not sure we are in capacity to run this marathon. And I think yeah, it's good to have some degree of freedom to adapt to new architecture.
Also, like, what do you want from a specification? Do you want security, that things are running the way you expect it to be? That's okay. You could do a specification for that, but then you lock yourself kind of in. Or you can just say, okay, whatever is in our documentation is a guarantee for now. If we change it, we will give you some transition time, but we reserve the right to just change it. Otherwise, we're just like committing for something that we might not be able to do in the end.
And then, like, when standard adoption occurs, right, you'll have to do negotiation on the specification as well as the code, right? and that
And I
get doubly hard, I think. It would be even harder to negotiate the specification, right?
And I guess everyone knows this comic about why there are so many flavors of Linux, because someone comes along and says, oh, this would be nice, and then just creates a new standard, or creates something new, some new specification, and tries to push it. I think it's for the C++ standard, like for that effort, it makes sense, but it needs to be condensed. And I don't see us as basically in a position to condense, or ourselves to be like already a condensed set, but stuff that we can condense and then push in the C++ standard, yeah, fine, but I don't see it for us.
Yeah, and about the security reason, if you look at Rust, that is considered as a secure language, the specification of Rust are what the compiler is currently doing. They have one compiler, and basically the compiler is the specification. So as long as there is only one Kokkos, perhaps we can live with that and improve the documentation, but we don't really need hard specification, I think.
Yeah, I think one last word I'll say on this is, while my position is maybe to not go toward full specification, it definitely does not absolve us from writing good documentation and clear documentation and as extensive as we can documentation. They're not the same thing. And I think on the other end, that an extremely clear and well-documented library is going to bring tremendous value for new users, current users, and people who want to understand what we're doing.
We stop on that good note that we need to document what we do. So the next question is, what piece of advice would you have to for a new user who want to get up and running with Kokkos? What advice do you have, and what common pitfall would you advise them against?
Yeah, I think the first advice is keep it the thing very simple at the beginning. Don't try to do premature optimization. And it's like for other libraries or language, but I think it's very important with Kokkos, if you want to keep the portability and the performance portability, to not try to over-optimize. So try with a simple parallelisms. Do not fall to hierarchical parallelisms from the beginning. You have to do profiling to see if you really need it, and keep things simple.
Yeah, exactly. It's like I said earlier, use the data. Use what your users are asking for, or whoever, your stakeholders, right? Use that, keep it simple, see what the data tells you, and then make it more complicated if you need to. And I think that's how we've been successful in implementing Kokkos through our stack.
Okay, so I would say it kind of depends on who is asking. If you are someone who is already in a C++ committee, then you probably can look at the implementation and get away with it. If you're not, then maybe stick to the documentation. If the documentation is not answering your question, go haunt us on Slack, because it's just better than you yourself digging through the tons of abstraction layers. Just go ask us. Like, that's why we have the Slack channel. That's why we should do a good job. If it also allows us to discover holes in our documentation or in our tutorials or whatever. If people come and say, hey, this is missing, this information is missing for me, or can you explain this? Because if you're a developer and you're looking at this, it's kind of like, yeah, you have the inside perspective. It's way clearer to you than to others. And sometimes it's hard to switch to an outside perspective just for writing documentation. So just come and haunt us. Like that's our part of our job, to explain what we're doing. And if we don't do a good job, just hit us with a stick and say you do a better job.
I'm going to say even one step lower. Do not go to the documentation, go to the Kokkos lectures online. You will get to hear the melodious voice of Christian Trott for, I don't know, a good 12 to 20 hours. So who would want, don't miss out. There's also training material, the Kokkos tutorials. So I think these are places where you can get started as well. Like if you really, if you're a student or if you're new to the, realm of HPC, there's so many things to learn. I will say like learning Kokkos for the sake of learning Kokkos is also not sufficient. I think to be able to look at the metrics and have like a data-driven approach, you need to also have a vague idea of like the computer architecture you're going to target. So there's so many things to take into consideration, I think. So take it easy. Go to the lecture, see a little bit what this is about. There will be some asides that are not part of Kokkos, but that are going to explain some things about GPUs and CPUs that are also quite useful.
Oh, and adding to that, Christian had a talk at CPPCon 2023 where he tried to condense his things that he like his lectures from 10 years of, or his takeaways from 10, I think it's 10 takeaways from 10 years of performance portability. And it's a rather abstract description, but it helps, at least for me, it helped me reason about how you should think in the setting of Kokkos. And I would definitely recommend watching this talk or the tutorials. It's more like, I would say, go watch the C++ talk, the CPPCon talk if you're intermediate or advanced beginner. Or just go and look at the tutorials, of course.
For onboarding like a new student, I think I would recommend reading the original paper that Carter Edwards and Christian wrote in 2014, which really introduces this idea of the data layouts and how you should change the data layout when you go from CPU to GPU. I think asking a student to read that paper and implement it in an example himself or herself is a great way to get started and get immediately the essence of the idea of the view. There is some old videos on YouTube as well where Carter is presenting from 2016, and he's sort of convincing the community with the initial ideas. And those videos are really interesting as well because they are still at the basic level and convincing people with the essential ideas.
So, apropos tutorials, some people are asking when new tutorials. I don't know if it means anything with their liking Christian voice, but
You mean tutorial or tutorial session?
tutorials.
Could be new material or could be the same.
I guess you can interpret it however you want.
Good question. Does anyone have an answer? Or is it
So I think we have tried to update the tutorials materials because if you look at the lecture, they are not up to date with current Kokkos. If you look at the slides, it's a little bit better. The GitHub repository has been redesigned, so now you have access to the source and you can help us fix things in the tutorials, in tutorial materials. But perhaps we have to modernize and to adapt to different kind of users. These tutorials are quite focused on, I will say, computer scientists. And for example, at CA, we have developed another small set of slides more focused on applied math people and physicists. it's less focused on C++. We don't want to go in details, and we will do like C-like imperative Kokkos with loops. So perhaps, yeah, we'll create new tutorials, and I think also for Fortran user, it can be great to have a specific set of tutorials to do the link between the Fortran array and the views and this kind of stuff. So, but if you have any ideas of what user you want us to target, I think it's the primary things to have is if we write or update the tutorials, what will be the audience.
Yeah, basically, come and tell us. If you want new tutorials, tell us and tell us what you want. Then we can try.
You know what's even better than ideas?
Doing it
Pull
yourself.
requests and contributions.
Yeah, just do it yourself. Great advice, Damia.
So one thing that one of the times at which we can look back on what we've done and what might require a new set of materials for tutorials is typically when we do our releases. We have a look back at what we've done, and we put that in the changelogs. And eventually we do a release briefing, and I think we could look at these briefings that we've done for, say, the past couple of years and see, have we released something that now we look at and we're like, hey, this was really new, this was important, and this was not clear because we got a lot of questions about it. And that typically hint at like, hey, we should probably write some kind of material to to clarify things, to explain them gently and bring people to like, hey, that's why we've done these things.
And I think also the current tutorials, one of the issues is they are really focused on Kokkos core, and the ecosystem is growing, so probably we will have to have a more well-balanced things between core, kernels, FFTs, COM, and this kind of ecosystem. And I think it can be close to the last question, is before trying to code in Kokkos, you have to check if it is not provided in the ecosystem.
Okay, this is going to be the last question. What's the Kokkos bus factor?
So you mean at
the bus factor is something that measured what it takes to take down the projects.
For the source code, or for the API, or
for the project
everything
function in general?
So,
everything?
Yeah, how many people, like in a bus, the driver, if he gets or her gets taken out, then the bus is doomed. So how many bus drivers do we have, basically?
I mean, I think the bus factor is greater than 1. I'm gonna speak for the libraries. Let's say the part of the ecosystem that selfishly includes core and kernels. That is, I guess the most established and in production, I would say. I'd say if you remove probably on the order of 2 to 3 of the folks from the library, from the team, you could do a good deal of damage. So it will take time to recover. There are some arcane locations of the libraries that are not known by a lot of folks. Yeah, I think bus factor of 3, I would say.
Okay, so I'm just gonna, if he brings up bus factor, then like normally cars are designed to drive straight if you let go of the wheel, right? So they not immediately just go and take a bend. Like if you just let go in your car from the steering wheel, just will continue running. It's not gonna immediately crash just because the driver is out of the seat or not paying attention or anything. Otherwise it would be horrible. So I guess it's hard to answer because we don't know who would step up or come back or whatever if the drivers are out of the seat. It might be that just someone who previously worked on the project is coming back, or someone else is stepping up, or it gets shared among more people. Like it's hard to answer. And it's not like just because for 1 second the bus drivers are away, everything is just going to fall apart.
So
It's going to be
I
hard.
agree, but it's in my understanding, it's a misunderstanding of the bus factor, what
Okay.
you're saying. Like, I agree with what you're saying, but I think the bus factor really implies if you remove a few folks right now, do you have a replacement immediately for these things? And I agree with you. There is inertia, and there will be people who will, naturally rise up and, take up the slack. But that's different from saying, if that person is away on vacation for like a month, like, do we see that things are somewhat floating and not, operating the way they should? And I'd say, yeah, if, this has happened already in the past, and we felt.
I've always heard it as, what's the minimum number of people that have to get hit by a bus for the project not to die?
Yeah.
It's like, how many people, or like, how many people need to be on different planes back to Sandia? Like, if you're all on the same flight, it's Kokkos end.
We're gonna let Isan go to a bridge.
Again, I think it's about 3 in my opinion. Yeah. I don't know, Damien, you're in a different position. Do you have an opinion on the bus factor of Kokkos?
I think we're in good shape. I think that there's another, so I learned recently there's another metric that's called the elephant factor, which this time, instead of looking at individual contributor, you look at organization. And you've seen what Christian has been showing you. Like, we depend less and less on of a single individual or organization. And yeah, that could hurt, but we'll be okay, I think. So we're out of time. Let's thank the speaker